Welcome students to lesson 21 of the natural hazards topic. In this lesson we build on our understanding of climate change from the previous lesson by looking at the main cause of climate change, which is the greenhouse effect. Please write the date, title and learning objective and have a pen and paper ready to learn. Time to review prior learning. We're going to do it a little differently this time. I'm going to show you some paragraphs. Use your understanding and from memory, put the words in the gaps and then mark your answers. Please write 1 to 18. Go for it. So number 1, climate change is the long-term change in the global patterns of temperature and precipitation. Global means it affects the whole world. The climate of a place is the average weather over a long period of time. It is about temperature and precipitation. For example, a hot desert's climate is hot and dry. Climate change does not mean that temperatures and rainfalls will change in the same way around the world. We have evidence of past and recent climate change. We drill for ice cores in Antarctica. The depth of the ice tells us the age of that ice. The amount of CO2 bubbles indicate the climate or temperature on Earth at that time. This type of evidence can tell us about the climate up to 2.7 million years ago. Another piece of evidence for past climate change is pollen samples. These become trapped in soil and buried underground. We dig up the soil. The depth shows the age. The type of pollen shows the type of plants that grew then. If we know the type of plant, we can work out the climate. Fossil records go furthest back in time. We can compare the plants locked in rocks to modern plants and guess the climate when they grew. Recent climate change is shown by the increase in temperature of about 0.9 to 1.1, that's fine, since 1880, and rising sea levels of about 21 centimetres since 1900. Give yourselves a mark out of 18. If you got 16 or more, fantastic. If not, go back to the previous lesson, watch the explanation again, and then come back and complete this. To introduce this lesson, I show you a photo and some questions. Use the photo and your understanding of it to answer the questions, and then we'll discuss the answers. Here's the photo. It's in Sweden, in Europe. So, what do you see? Well, you should have said that you see a house inside a greenhouse with trees surrounding it. 2, why do you think the house is in the greenhouse? Well, if you understand how a greenhouse works, then you would have explained that the house is in the greenhouse to keep warm, because greenhouses make what's within them warmer. 3, how does this relate to global warming? Well, you may have heard of the greenhouse effect. The idea that the Earth gets warmer because of something going on in the atmosphere, similar to how a greenhouse works. Well, in this lesson, I'm going to help you understand that important principle, that the world's atmosphere is in some ways similar to a greenhouse. And we, human beings, through our different activities, can make the greenhouse effect stronger, and so make the interior of the Earth's atmosphere, much like the interior of a greenhouse, warmer. Let's go. So the first question, the big one, is how does a greenhouse work? Well, if you shine light through a prism, a piece of glass like this, at the correct angle, then the light will be split up into its various colours, and it'll come out in lots of different colours like that, much like a rainbow. Because in fact, light is not just white light, light is a combination of all these colours. We call this visible light. But what you may not know is that light is in fact a wave, kind of like this, and this, and this. You can have very short wavelength light, which is where the waves are very short like this, or you can have very long wavelength light like this, where the waves are very spread out. Visible light, the light that we can see, occupies this area here. It's much shorter than this, but much longer than this. Now, the big idea is this. Some types of light that we see are shorter than others. For example, ultraviolet light, which is what gives you a tan, that is the shortest wavelength of the visible light. You can't actually see it, so it's just beyond visible light here. By contrast, some types of light that reach Earth are longer wavelength, for example infrared, which we feel as heat. This is really important because the type of light that comes from the sun is mostly ultraviolet light, like this, shorter wavelength. So here's what happens in a greenhouse. The sun transmits short wavelength light through Earth's atmosphere to the greenhouse. That short wavelength light has no problem going through the glass of the greenhouse. It goes straight through and hits the ground within the greenhouse. When the short wavelength light hits the ground, it is absorbed by the ground, causing the ground to heat up. And that heated up ground re-emits, which means sends back out, long wavelength light called infrared, which we feel as heat. And that heat cannot pass through glass nearly as easily as the short wavelength UV light can. And consequently that heat builds up within the greenhouse, and so the greenhouse gets warmer. So, big idea. Short wavelength light passes through the greenhouse. Long wavelength light is trapped. The short wavelength light is called ultraviolet, and the long wavelength light infrared. The Earth's atmosphere behaves very similarly to a greenhouse. Let me show you. Here's your greenhouse. Now, of course, the Earth's atmosphere does not have a layer of glass all around it. So how can infrared light that's being absorbed, that's being re-emitted by the ground, how can that be trapped within the Earth's atmosphere? Well, much like the glass in the greenhouse, the Earth's atmosphere lets ultraviolet light straight through. But within the Earth's atmosphere are these gases. These are called greenhouse gases, and here's what they do. Greenhouse gases are spread around Earth's atmosphere. And these greenhouse gases, much like glass in a greenhouse, allow ultraviolet light to pass right through them. They don't trap or reflect them. However, when the sunlight hits the ground on Earth and heats up the ground, and that light is then re-emitted as infrared heat, the infrared hits these greenhouse gases in the atmosphere and is absorbed by them and re-emitted back into Earth's atmosphere. The infrared is trapped, and consequently the Earth's atmosphere warms up, much like a greenhouse. The main greenhouse gases are carbon dioxide, CO2, methane, CH4, water vapor, H2O, and nitrous oxide, N2O, but there are others. All of these greenhouse gases have the same property, which means they all allow ultraviolet light to come in, short wavelength light, but they all trap long wavelength light, infrared, and consequently they all contribute to making the Earth's atmosphere warmer. Now, the greenhouse effect has always existed within Earth's atmosphere. That's why the whole of the Earth is not frozen. It's why life is possible. It's why plants can grow. But here's what the greenhouse effect looks like in the real world. So you have, at number 1, short wavelength light coming from the sun through Earth's atmosphere. And as you see, the short wavelength light easily passes through the greenhouse gases in the atmosphere, H2O, CO2, CH4. At number 2, the short wavelength light is absorbed by the sea and by the ground and is re-emitted through these orange lines as long wavelength light, infrared. The long wavelength light then hits the greenhouse gases in the Earth's atmosphere, CO2, H2O, CH4. And much of that long wavelength light is re-emitted back into Earth's atmosphere, as you see here, trapping it. Some of it escapes to space, but some of it is trapped, as you can see here. As a result of the presence of greenhouse gases in Earth's atmosphere, the Earth's atmosphere gets warmer. Now, the big idea for climate change today is that the amount, known as the concentration, of these greenhouse gases in the atmosphere is increasing. meaning that more infrared is being trapped within Earth's atmosphere than before. And so the Earth's atmosphere is getting warmer than it was. But that's the story of next lesson. Some basic questions to assess your learning. Question 1. What type of light comes from the sun to the Earth? You should have said short wavelength light, for example UV. Question 2. What happens to UV light when it hits glass, like in a greenhouse? UV light goes straight through glass. It's not blocked or reflected by it. 3. What happens to UV light when it hits the ground on Earth or the sea? You should have said it's absorbed by the ground or the sea and re-emitted as heat, also known as infrared. Long wavelength light. And finally, give me 2 examples of greenhouse gases and tell me what they do to infrared light. You could have said CO2, or H2O, or CH4, methane, or nitrous oxide. And then you finally should have said that these greenhouse gases absorb and trap long wavelength light within Earth's atmosphere. Okay. Time to really embed learning. I'm going to show you a question. Use the sentence starters to answer this question so that you master the idea of the greenhouse effect. Make sure you use all these keywords. Start with this sentence, finish it off, then this sentence, then this sentence, then this sentence. And then mark your answers out of 4. 1 mark for each part. So, mark your answers. Make sure you have all 4 of these parts explained as I have. If you're missing any part, add it in green pen. If you got any part wrong, such as short wavelength and long wavelength, correct it. Give yourselves a mark out of 4. Underline every time you use one of these keywords. Add them in to the correct place if you haven't used one of them. From this lesson, write 2 questions from memory. Write their answers and then test yourselves on them and the previous questions from other lessons that you have written. Thank you so much for joining me this lesson. Next lesson we're going to be looking at the causes of climate change. Join me then.